sorry about that. The phone ringing. So these neural systems are recent offerings from these vendors, and then Google Translate baseline, and then you can see some of our systems in here as well. And so what you see is this sort of distribution of systems relative to BLEU score, and you get down to these few top systems that are all separated by about 1 BLEU point here. Now, 1 BLEU point is usually a difference, 1 to 2 BLEU points is a difference that human raters can detect. So in here we have these systems that are all clustered kind of together, and we might want to say that, okay, we know that 1 BLEU point humans can kind of detect, so we can eliminate this whole block of systems for human evaluation and instead focus on these 3 systems right here. And these differences are not statistically significant, and what I mean by statistical significance is a very concrete quantitative claim about random chance explaining the outcome of what we see. So in this case, what I mean by not statistically significant is I can't make a statement that if we were to select another set of content that we'd see these same differences amongst these systems. So basically what I'm saying is even though the BLEU score is slightly different, we can't actually make the statement that any one of these systems are better than the others. So we need to go onto a human evaluation to confirm that fact. English to German, we see something similar. So you see, again, an ordering of the systems. Some of the baseline phrase-based systems are lower on the list, and you see some of the neural systems are much better. And then you see this kind of division with the domain-adapted system. So, Microsoft's adapted system, there's a nice jump from their baseline system of 24.8 to 27.6. Likewise, for our system, you get a nice jump when you add in some TM data to make a custom MT system. And then Google's neural system is just very strong without any TM training. But again, the differences here between these 4 systems are very, very close. And actually, the differences are not statistically significant. So we don't actually know which one of these systems is better. So again, we maybe want to select this subset to go on for human evaluation. So what we conclude here is that 1 to 2 BLEU margin is usually noticeable to human raters. If we look at our chart, we see that Google's neural MT system and the LILT system are at the top of the list. And if we look at English to German, Google's neural system, LILT system, and then Microsoft Translator Hub are at the top of the list. So we could take those 3 systems and evaluate them, or we could down select to 2 different systems, either one. But the case is we've gone now from a universe of 11 systems down to 2 that we want to focus on for human translation evaluation. And so we've thus considerably reduced the time and expense of the human evaluation. Evaluating all 11 systems would take a lot of time and cost a lot of money, but it's much faster and cheaper to evaluate 2 different systems. And because of the assumptions that we've made about how we've set up the evaluation, we have some reasonable belief that were we to evaluate all 11 systems, we'd arrive at the same conclusion. Okay, so now let's go briefly through human evaluation of quality. Now our core principles here are going to be that it's going to be anonymous, so the raters don't know the system identities. We're going to select a subset of the data, so we're going to take 100 sentences out of the 1,300 that were in the automatic evaluation. Evaluating all 1,300 would be pretty expensive, but we're just going to randomly sample 100. You could make that sample higher or lower depending on how much time and money you have. And we're going to collect a couple different ratings for each pair of outputs from the 2 systems we're looking at, in this case, the Google Neural System and the LILT system. And we're going to also provide reference translations for the human raters to look at. And crucially, we don't want those to come from post-editing because we don't want there to be any influence from machine translation there. Okay, so our rating options are kind of doing a pairwise evaluation like we did with close, or it's also not bad to use a Likert scale where you put 2 sentences next to each other and you ask people to rate. So here's an example interface that's commonly used in research. Here you have the source sentence and you have 2 machine translation outputs. You can see that they're anonymized, so it just says translation system 1 and translation system 2. We don't know, the rater doesn't know which systems these are to eliminate bias. There's a reference translation here that the human translator can look at that came from a human translator. And then they can rank the two outputs, so they could, say this is a 1 and this is a 3. And so from this kind of an interface, we can get pairwise assessments. So we can say that like 2 is better than 1, or we could also use these more granular numbers. But crucially, these numbers are assigned in a comparative fashion. So you're kind of saying like, yeah, this is good. If this is a 1, then this is kind of a 3. So there's still this comparative element to making the translation evaluations, rather than just looking at machine translation output number 1 and assigning, let's say, like a score of 1 to 10 to it without any reference to anything else. Okay, so that's sort of really exactly how this 2016 Google Human evaluation was set up. They compared their neural MT system to their statistical machine translation system. Humans were rating, this is a typo, they were rating 3 different translations given a source sentence on a scale from 0 to 6. So in this interface, there's a sort of 1 to 5 scale. In the Google system interface, there's 0 to 6. But it doesn't really matter. It doesn't really matter. I think probably 10 levels on the scale is probably too much, but 5 or 6 is okay. And so they looked at Google Translate Premium, and then they also interleaved reference human translations amongst the raters so that they could see how good these systems were relative to a human translating the source sentence. And these were the results. And this is kind of the headline table in the paper that got most of the attention, which is that what they did was, instead of showing pairwise evaluations, they just took the average score assigned to each translation and then just took an average here. So what you can see is in this this comparative human evaluation they did, the human translations for English to Spanish got an average of 5.5, where 6 is the highest score. And then what was impressive was there's this kind of jump from the statistical system to the neural system. So sort of consistently across language pairs, human raters were rating the neural system as better than the statistical system. And more importantly, the scores were getting very close to the ratings that were given to human reference translations. Now, what's important here to note is that this is a structured evaluation. It's set up according to the principles that we talked about. It's not saying that translation is solved. All it's really saying is that for a particular data set and a particular set of reference translations generated by some people, the neural system is sort of getting ratings that are very close to the human translations. And so instead of asking questions like, how good is neural MT, all they're kind of saying is, how good are these system outputs relative to human translation and relative to the statistical machine translation output. That's not a general claim about how good these human translations are. And in fact, that's maybe if you could level one critique at this, you could say that, well, how good were these human translations? Were they reviewed really carefully? Where did they come from? Who did them? And so on, because that's going to influence this whole project here. How good these sort of human references are. Okay, so we've got just a few minutes left, so I'll show you how you can do this yourself very quickly with a spreadsheet. And so I'll just take 2 minutes here. You don't need a fancy interface to do this. What I've done here is taken a sentence from the Count of Monte Cristo, and I have translated it with the Lilt system and with the Google system. So you can see here what's the source sentence and what's the output of the two different machine translation systems. And if we were going to send this to some raters, we'd have a spreadsheet that looks like this. And this is what we would actually show people. So we would have system A and system B. The system identities are anonymized. We have a reference translation. This actually comes from the 1888 translation of the Count of Monte Cristo. So it's not to say that this is the perfect translation of this particular sentence, but it's coming from a human reference translation that obviously wasn't generated with machine translation and is accepted as a pretty good translation of this sentence. And all we do was we would just start taking the machine taking the machine translation outputs and sort of randomly assigning them to these columns. So we might put lilt here, and we might put then lilt here, and then we might put lilt here, let's say, and then we could pick the Google system. Let's put that here under System A, and then we'll take these two and put those here. So crucially, when the human rater comes in to look at the spreadsheet, they don't know what System A and System B are. And all that they're going to do is they're going to come in here and put their rating. So if we did a pairwise rating, you could say something like, for this, the translations are equal, and they're very similar to the reference. So the human rater might say A is equal to B. If we looked at this one, so we have shouted the man in the boat, cried the man in the boat, and the reference translation is cried the man in the skiff. Well, we might, I don't know, we might key on this word cried and say that that matches the reference. So we might say that B is greater than A. And then here we get down to this one, what happened and why this arrow of sadness spread on your edge. What happened then and why that arrow of sadness spread over your whole edge? Well, I don't know, it's hard to say. They're both kind of bad, but maybe this one's a little bit more verbose and doesn't correspond to the source. So we'll just say that A is greater than B here. So now, assuming that you need, of course, to remember where you put the identities of each one of these outputs, so that then you can go in and start tabulate which one is better than the other. And you can make a simple table. If you do this over 100 sentences, you'll sort of start to see a histogram, just like we created earlier for the clothing evaluation. And what you'd like to see is that there's a very obvious preference for one system over the other. And you can also look at the individual human raters to see if you've had, say, 3 different people rate this sentence, that you get a consistent judgment from those 3 different people for this sentence. Okay, so that's a really simple and fast way to do the exact same kind of evaluation that Google does and that lots of other people do for evaluating translation quality. You can do it in a very simple spreadsheet. I could send this spreadsheet to a linguist and have them fill in these judgments really quickly, and then I could very quickly make that same histogram that I showed you before, and have really a quantitative evaluation of human translation quality. Okay, so we're a few minutes over time. I'll just wrap up. What we've talked about today is doing an automatic quality evaluation first to narrow the list of systems. And if you kind of have accounts and you're set up correctly, you can do this really quickly, like in 1 to 2 days. Narrow down the list of systems you're going to look at. You can then do a human quality evaluation. I've just shown you how to do that really cheaply and quickly in a spreadsheet. That, depending on how long you want to take and how many sentences you want to evaluate, that can take, say a week, let's say. And then you could move on to a human productivity evaluation, knowing that input machine translation quality, it's kind of well known that that's correlated with post-editing time. That's a more complicated setup, and we'll save that for a future webinar. But the general takeaway that I want you to take away from this is that we've used a very structured evaluation setup to be able to make sort of generalizable, repeatable, and reproducible claims about different systems. And then if we were to do that several different times, we generally hope what the goal is that we have the same result each time. And so that's very different than ad hoc testing or error counting, where you're just kind of taking a few sentences, putting them into an MT system, and having some rough idea of what's good or bad, and kind of making an assessment. Instead, we've gone very systematically through, in our case, 11 different systems, and narrowed that down to a list of 2, and made very concrete and quantified statements about those systems. So that's the last slide. Thanks for joining today. Like I said, my email is here. So if you're happy to receive email and take additional questions about this, we'll post the slides later in the day, or hopefully by tomorrow, and we'll look forward to hearing from you. So I've got a minute or 2 for questions. Otherwise, send me questions by email, and thanks for joining today. You can use the chat window, or there's also a QA window. All right, any questions? All right, everyone. Thanks so much for joining today. I hope you have a great day, and look forward to getting your questions by email or hearing from you through social media. Take care. Have a great day.